Here in module 5 lecture 4 that we will discuss about three different functions. One is kill function, one more is alarm function, one more is interval functions. All three functions are supposed to use to process supposed to suspended or supposed to perform the operation after some milliseconds, or you want to go for provide some interval timings. For that we are using this module with the lecturer 5 concepts. Kill API. A kill API is used to kill the suspended or hanging process or process groups. Not only one, maybe more than one process. They are hanging it out or suspending those when the process should be completed using with the help of kill function or kill API. API signal transporter and can send specified signal to specified process in the Unix operating system. The sender and recipient process must be related such that either sender process real or effective user ID matches that all of the recipient process or the sender as super user. Sender as super user privileges. For example, the parent and child process can send signals to each other through the kill API function or nothing but kill using kill API functions. A kill API is defined in most Unix systems and POSIX 1 standards. A process can send a signal to a related process via the kill API or kill function. This is a simple means of interprocess communication or control. The sender and recipient process must be related such that earlier sender real reals or effective user ID matches that of the recipient process, or the sender has super super privileges. For example, the parent and child process can send signals to each other through a kill API or kill function. A kill API defines in most Unix system and in a POSIX 1 standard. The function prototype of kill function or kill API is that includes a signal.h header file and written in the form of integer type with two parameters. One is PID, one is a signal number. The signal number argument is the integer value of the signal to be set to one or more process designated by the PID, nothing but process ID. The possible value of PID and its use by the kill API are a positive value. PID is process ID, send signal number to the process. Process ID value is 0. The sends signal number to all process whose process group ID is the names of the calling process. If it is process PID is -1, send signal number to all processors whose real user ID is the same as the effective user ID of the calling process. If the calling process effective user ID is a super user ID or SU user ID, then signal number will be sent to all processors in the system, nothing but except process -0 and 1. The latter case is used when the system is shutting down. Kernel calls the kill API to terminate all processes except 0 and 1. For this, usually the particular API, kill API, behaves of just like a POSIX1 does not behave like a kill API. When process ID value is -1, this affects the Unix system only. A negative value, if the PID value is negative value, send signal number to all the process whose process group ID matches the absolute value of the process ID. The result of kill function is 0 if it is succeed, otherwise -1 if it is fails. Generally, we are consider whatever value you are consider. If the PID is positive, then signal NG is the PID. If it is PID equals to 0, then the specific value or the given argument is sent to every process in the process group of the current process. If PID equal to -1, then the SIG is set the every process for which the calling process has permissions to send signals except the process 1, nothing but init function, nothing but initialization of function, but whatever things are there that can be happened. If PID is less than -1, then the specific SID is sent to server process and the process group is PID. Like that, this function is performed and then produce the different values based on what type of the result is written from the corresponding kill function. The following program illustrate the implementation of using kill function or kill API as a Unix kill command. Here that includes 4 different header files: iostream.h, sto.h, unix standard.h, string.h, and also signal.h header files. And the main function returns is the integer type value with the corresponding int argument with the character argument array. If PID SIG is equal to SIG term, that is equivalent to whatever assigned the SIG value assigned to SIG term, nothing but signal term. If ERGC is equal to 3, then the particular SSCANF ERGV1 is equal to percentage D, nothing but integer value of SIG, not equal to 1. To get the signal number, the error invalid number, and print the corresponding argument 1 and returns -1. If then increment ARG plus nothing but second value should be taken from the array with the corresponding integer argument of decrement the integer argument, whatever int ARGC is there, that should be decremented and increment array values, arrays. While the argument C, nothing but whatever the integer type value is there that is greater than 0, then you want to perform specifics scanf with the corresponding pointer with argument v, nothing but array of the argument, then and you want to go for mention PID is equal to 1 to get the process ID, nothing but you want to identify the ID. If kill PID process ID as I said is equal to -1, then prior the call the corresponding kill function, otherwise it's supposed to go for call an error, nothing but invalid PID, then print a specific array value and return 0 value to the corresponding function. This is actual thing should be performed when the kill function is called or kill program is supposed to execute it. The alarm API can be called by a process to request the kernel to send the SIG alarm signal after certain number of real clock seconds. The alarm API is defined in most Unix systems and is POSIX 1 standard. Nothing but you set a specific seconds, then the clock supposed to go for set that. After that only the thing should be performed. The function prototype of alarm API is included signal.h error file and also return the specific integer. Unsigned integer number value is printed. Unsigned means only positive value. Signed means positive and negative value. Unsigned int time should be interval for a specific of a alarm function execution. The time interval argument is the number of CPU seconds elapses time, nothing but completed time, after which the kernel will send the specific SIG alarm, nothing but signal alarm signal to the calling process. Here, if the time interval value is 0, if this returns off the alarm clock. In the return value of the alarm API is the number of CPU seconds left in the process timer as set by the previous alarm system call. The effect of the previous alarm API is cancelled and the process timer is reset with the new alarm call. And then later the process alarm clock is not passed on to its forked children process, but whatever an execcd process certain the same alarm clock value as was prior to the execution API call. Like this we can suppose to go for using some operations we performed with the help of the specific alarm function is executed. The alarm API can be used to implement the sleep API. Here, whatever the value that return with the sleep method, that is unsigned integer, nothing but only the positive value. That's supposed to call structure sig auction and other action is there. Specific sig auction structure that contain number of parameters that included with the help of the structure variable action. Action at as handler is equal to wake up, then action f flag is equal to 0. If it is like that, then you will consider sig emt set value should be considered with the help of a return address type of action sec mask is there. Like that we can consider all the operations with the help of signal statements. If sig action, sig alarm and action is equal to less than 1, then you can supposed to print the prior error sig action and return a -1 value. Otherwise, valid alarm timer is finalized, then update the parent in pause function should be called and then perform the operation of pause. Here, the sleep function sets up a signal handler for the SIG alarm. Call the alarm API to request the kernel to send SIG alarm signal after the timer interval and finally suspend its execution via the pause system call. The wake up signal handler function is called when sig alarm signal is sent to the process. When it returns, the pause system call will be aborted and the calling process will return from the sleep function. Here BSD Unix defines the alarm function, which is same as the alarm API, except that argument and return value of the alarm functions are in microseconds units. Nothing but it's a fraction of seconds. Those things should be called and then perform the operation using with the specific alarm after elapsing of a corresponding microseconds. Microseconds are completed. Here we are discuss about interval timers. The use of alarm API is to set up the interval timer in a process. The interval timer can be used in scheduled a process to do some task at a fixed time of interval to time the execution of some operations or limit the time allowed for the execution of some task or given work. Then the use of alarm API is to set the interval timer in a process in microseconds. The interval timer can be used to schedule the process to do some task at a fixed time interval to the execution of some operations. Here the following program illustrates how to set up the real-time clock interval timer using the alarm API or alarm function. That include 3 header files, one standard input-output file, one Unix standard header file, and also signal header file. And also you can define interval time is 5. Void call me function is called with the help of a signal number. If you call alarm with a specific interval time 5 microseconds or 5 milliseconds, the scheduled task should be performed after that interval time. The main function returns integer type of value corresponding structure sig action. Structure with sig action with the action variable is supposed to declare for the structure sig action. Here sig empty sets that's supposed to go for perform the operation with the mass function. Finally, we want to go for using action as a handler with the void return type with the call me function, and then whatever the flags are there, all the flags are restart. If sig action, sig alarm and action is 0 with -1, that's supposed to go for perform the error sig action and return 1 value. If alarm interval is equal to -1, then it's supposed to provide only the alarm. Else you want to go for check the while value is there, then do normal operations, otherwise return 0. The sig action function is called to set up call me as the signal handling function for the sig alarm signal. The program then invokes the alarm API to send itself with the sig alarm signal after 5 real clock seconds. The program then gives off the perform its normal operation in an infinite loop. When the timer expires, the call me function is invoked with restart the alarm clock for action 5 seconds and then does the scheduled tasks. When the calling function returns, the program continues its normal operation until another user expiration. The BSD Unix inverted the specific Setitimer API, which provides capabilities additional to those of the alarm API. The set timer set I timer resolves the time is in microseconds, whereas the resolution time for alarm is in seconds. The alarm can be used to set up real-time clock timer per process. The set timer API can be used to define up three different types of timer in a process. One is real-time clock timer. Second one is time based on user time spent by the process. Third one, time based on total user and the system time spent by the process. Usually we consider the get timer API is also defined in BSD and system V Unix for the user to query the timer value that are set by the setting API. The set timer and get timer function prototypes are written in the form of two written values with different parameters, usually which are the corresponding arguments are there, which arguments specifies the timer in process, and possible values are ITI MER real, nothing but real based on real time clock, generates a SIG alarm signal when expires. ITI MER VRTUAL virtual, then timer based on user time spent by the process generates a SIG VTALRM signal when it expires. Then ITI MER PROF, nothing but a timer based on the total user and system time spent by a process generates SIG PROF signal when it expires. The structure interval data type is defined in the system or the time.h header file. As the structure interval we consider that contain two variables, one is timer interval, second one is current value. For set timer API, the value IT value is the time to set the named timer, and the value IT interval is to timer to reload the timer when it expires. The value IT interval may be set 0 if the timer is to run only once, and if the value is IT is set to 0, it stops the named timer if it is running. For get IT IMER function or API, old IT value and the old IT interval returns the named timer's remaining time and the related time respectively. The old argument of this set IT IMER API is like old argument of get IT IMER API. If this is the address of a structure interval type variable, it returns the previous timer value. If set a null and old timer value will not be returned. The timer virtual and timer proof timers are primarily useful in timing the total execution time of a selected user function, as the timer runs only while the user process is running, or a kernel is executing system function on behalf of the user process for iTimer VROF timer. I think what this is one of the the value consider. Both of API returns 0, no such R minus 1 if they failed. Timer set by the Setitimer API in a present process are not inherited by in child processes, but these timers are retained when the process executes a new program. Usually we consider the program that possible to go for using it that generates different values, and finally the specific set itmer and alarmAPI requires the user set up signals handling to each timer expiration. They should not be used to conjunction with the sleep API because sleep API may modify the signal handling function for the SIG alarm signal.